Hello fans, welcome to Chemistry Pathway. We are going to talk about today factors affecting the preferential discharge of ion from solution. Factors affecting the preferential discharge of ions from solution. So here now, there are some factors that determine the ion that will be going to the electrode to either lose electron or accept electron. Yes. And these three factors, number one, include the position of the ion in the activity series. The position of ion in the activity series. The position of ion in the activity series. So now, before we proceed, what is activity series? Activity series is just a chart that shows the reactivity of ions, or it's just a chart that shows the order of reactivity of ions. Yes, in ascending order. It's a chart that shows the activity of ions in an ascending order, or anyone in an ascending order. Now, any ion that is lower than hydrogen in the activity series is the one that is likely to be discharged from solution. Why? Because this type of ions doesn't struggle to accept or give out electrons. But the ones that are higher than hydrogen in the activity series are not readily discharged from solution. This set of ions doesn't give out electron or accept electron easily. So now, assuming I have I'm to conduct the electrolysis of dilute sodium chloride. I'm to conduct the electrolysis of dilute sodium chloride using double electrode. At the cation section, I have sodium ion, and I have chloride ion. Sorry, and I have hydrogen ion. And at the anion section, I'm having chloride ion and hydroxide ion. Now, at the cation section, by virtue of the position of ion in the electrochemical series, it will be hydrogen ion that will liberated because it is higher, it is lower than sodium ion in the activity series. So when hydrogen ion migrates to the cathode, it accepts what? It accepts how many electrons? It accepts one electron. Plus one electron to be what? Hydrogen atom. Then hydrogen atom combines with another hydrogen atom to give you hydrogen as a gas. Remember that reduction takes place at the what? Cathode. What is reduction reaction? Reduction reaction is just a reaction whereby what? Electrons are gained. Yes. So at the cathode now, hydrogen gas is liberated. Why? By the virtue of its position in the activity series. While at the anion section, it will be chloride ion that will be migrating to the what? To the anode. And when hydroxide ion will migrate to the anode, this is what happens. This is the oxidation reaction that will take place, because oxidation reaction takes place at the what? At the anode. This is where we have what? Loss of electron. So this is where we will be looking at. Plus hydroxide was atom. Then hydroxide atom combines with another hydroxide atom to give you one molecule of water plus oxygen as an atom. Because of the unstability of this oxygen atom, is unstable, so it has to combine with another oxygen atom to give you oxygen as a what? Gas. So at the anode, oxygen gas is liberated, while at the cathode, hydrogen gas is what? Liberated. Why? By the virtue of their position in the activity series. Remember I told you that those ones that are higher than hydrogen in the activity series are not preferentially discharged, while the ones that are lower than hydrogen in the activity series are preferential discharged, because they don't struggle to give out or accept electrons. So that is that for number one. Then number two, we have concentration of ions. Number two, we have concentration of ions. to up, iron tends to increase in their concentration. But when you are going from up to down, there is decrease in the concentration of what? Ions. So now, let me give you an instance. Assume I'm asked to conduct an electrolysis of concentrated sodium chloride. Concentrated sodium chloride, otherwise known as what? Brine. So here you call it concentrated sodium chloride, or you call it brine. Now, at the cation section, I have sodium ion and what? Hydrogen ion. This is for cations. Then at the anions, I have chloride ion and what? Hydroxide ion. Now, at the cation section, hydrogen is supposed to be sodium that will go, that will be liberated. Is it not? Yes. Why? Because it is more concentrated than hydrogen in the activity series. It's more concentrated than hydrogen in the activity series. Now, concentration, let me tell you, it also has effect here now because the two ions are far apart. The two ions are far apart in the activity series. So concentration doesn't have effect here. So instead of sodium ion to be liberated, it will be hydrogen ion that will be liberated. Why? Because the two ions are far apart. So when hydrogen ion is liberated, oxidation reaction takes place. So hydrogen ion connects one electron to be deposited as hydrogen atom. Hydrogen atom then combines with another hydrogen atom to give you hydrogen as a gas. So at the cathode, hydrogen gas is what? Liberated. Now at the anode, let's look at the effect of concentration at the anode. I have chloride ion and I have hydroxide ion. Now concentration really have effect here because the two ions are close to each other in the activity series. Yes, so it will be chloride ion that will what? Preferentially discharged. Why? Because it is more concentrated than hydroxide ion in the activity series. So when chloride ion is discharged, oxidation reaction takes place there. So this will give us chloride ion losing one electron plus chlorine. Yes. So chlorine atom combines with another chlorine atom to give you chlorine as a what? Gas. So this is chlorine gas is liberated at the what? And by the virtue of this what? Concentration. Why? Because it is more concentrated than hydroxide ion in the activity series. So that is that for concentration of ions. Now we go to the what? The nature of electrode. Yes, it also has effect on the preferential discharge of ion from solution. Nature of electrodes. Nature of electrodes. We have nature of electrodes. Now there are some certain electrodes that interfere in electrolytic reaction. Why some doesn't interfere with what is going on in the electrolytic cell. Those ones that doesn't interfere with the electrolytic reaction, we call them what? Inert electrode. We call them inert electrode. And what are these inert electrodes? They include what? We have carbon electrode, we have platinum electrode, and we have graphite electrode. Yes, this set of electrodes doesn't interfere with what is going on in the electrolytic cell. And we have ones that what? Interfere with the electrolytic reaction. Examples of those ones include what? We have mercury electrode, we have mercury electrode, and we have copper electrode. We have mercury electrode and we have copper electrode. Now again, assuming I'm asked to conduct the electrolysis of dilute sodium chloride using mercury electrode. Now at the cation section, I'm supposed to have sodium ion and hydrogen ion. And at the anion section, I'm supposed to have chloride ion and hydroxide ion. Now, normally it's supposed to be hydrogen that is supposed to be preferentially discharged. But because mercury as an electrode, because it's mercury electrode I'm using now to conduct this electrolysis of dilute sodium chloride. Because mercury has affinity for sodium, it will be the one that will discharge instead of